Okay, last time we learned the basics of exponential form, logarithmic form. Okay, so a couple of things. If you're going to do an exponent, okay, you don't need to write this down, something like this, 3 squared, and then we figure out what it equals. So this was kind of the deal. We would input the exponent, and we would get output, which was the result. Okay, that's what your brain normally does. It's like you put something in, what do you get out? So if you put in the exponent 2, you get out a 9. So then we learned about logs. Do you remember that that's how it worked? Log 3, 9. So then this was the base, this was the result, and we were trying to figure out what exponent it equaled. So this time it's going to be flipped around. We're going to input the results. So logs make you output, well, what is the exponent? Okay? So it's like that backwards thinking. But our input and our output are going to be backwards, which is when you graph, your x and your y coordinates are going to have to switch around because of the input-output. Okay, so here's an exponential function. So like I said, we're going to have a number to an exponent, and it will equal some result. So x input is the exponent, y is the output, the result. And then what could we do? We could do an a, b, a c, or a d yet. Okay, so a is always the multiplier at the front, b is always the multiplier in front of the x, c is with the x, d is the outside number, right? It's the same kind of format. So then this is the logarithmic. So again, it's a little bit backwards. This time x is the result, y is the exponent. Okay, and then we could add some a's, b's, c's, and d's in there as well. Okay, so here we go. Let's graph. So what kind of format would you say this is? A log or exponent? What kind of format does it show us? Exponential form, right? Okay, so the base is 3. So I usually pick these x values and I plug it in and I see what I get. Okay, so what is 3 to the negative 1? What is 3 to the 0? What is 3 to the 1? Okay, I'll start down here. This is the easiest. What is 3 to the 1? Just 3. What is anything to the 0? 1. What does the negative exponent do? Do you remember that rule? 1 over. It makes it go down to the bottom, so 1/3. Okay, so those are the 3 kind of core points. If you wanted to keep going, you could. This would be 3 squared, 9, 27. What would this be? Can anybody do that? Mental math there? 1 over 9. Okay, so coordinates. 0, 1, 1 comma 3, negative 1 comma 1/3. Okay, would you agree that as you move right, you're just going to be going up, 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 up? Because we went to 9 and then 27. Like, it's going up pretty quickly. And then what do you think I'm going to do as I move left? So the next was like 1/9. And then 1 over 27. And then So what am I doing to my numbers? I'm getting closer to 0, but never hitting it. So what should I now draw? If I get closer and closer to something on a graph, I need to draw a asymptote. Okay, so you are going to always have the coordinate 0, 1, because any number to the 0 is 1. You are always going to have an asymptote at y equals 0, because it's a flat one. And you would always have the coordinate 1 comma your base. So you could see here we had the coordinate 1 comma 3. Because whatever you have to the 1, it's just going to be itself. Okay, so that's kind of like a AAA memory thing. Those 3 A's, what you always kind of start with. But there's going to be transformations at some point. So obviously if I'm moving, this point could move somewhere. What could happen? What's the only way to move this asymptote? Which one, A, B, C, or D, would move this asymptote? Which transformation could move it? What if I moved left or right? Would that move? No. So the only thing to do is move it up and down, right? Okay, next one. This time the base is 1/2. Okay, so I'm going to go over here. I'm going to go 1/2 to the -1, 1/2 to the 0, 1/2 to the 1. Kind of do my foundation. Those are the 3 points I always pick. Okay, so anything to the 1 is just itself. Anything to the 0 is 1. Does anybody know what would happen here if I did this to a negative exponent? What would it be? You would have to do what? Move it. Move the fraction, right? So 2. So then this would technically be what? 4, 2 squared, 1 over 4, 1 over 8, right? 2 cubed is 8. Okay, so if we graph it, we have the coordinate 0, 1. 1 comma 1/2 and -1 comma 2. Okay, so what's the pattern here? It looks like it would go up that way, but then on this side to the right, it will be getting smaller, 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 smaller. Okay, and again, there's an asymptote there. Okay, so what's the difference between this one and the last one? So this one, the base is less than 1, so it will decrease. Okay, exponential growth gets used all the time for like population. What if you like got a disease with your deer and every day the population was half of what it was, half of what it was, half of what it was? Okay, it's going down, it's decreasing. So looking at your last one here that we graphed, this time on this one the base was 3. So the base was bigger than 1, so what is it going to do? It's going to grow. It's going to increase. Okay, so does that make sense with bases? If your base is more than 1, you're growing something, and if it's less than 1, you're going to decrease something. Okay, looking at the next one. Can you identify the base? So this is an exponential. Can you identify what the base is? 2. So can you go 2 to the negative 1, 2 to the 0, 2 to the 1? So we're going to do just a bunch of exponents. So those are the 3 I always pick. So this is a half, 1, 2. So this is the coordinate. Exponent, comma, result. Exponent, comma, result. Exponent, comma, result. Okay, what did I do this time? I put some transformations into this. Okay, so what is the 3? Give me an A, a B, a C, or a D. C, and then that means that's a D. What do you do with your coordinates? X minus 3, right? Left 3, and then Y subtract 1, down 1. Okay, so can you change all those coordinates? So negative 1 subtract 3 is negative 4, comma 1/2 subtract 1 is negative 1/2. 0 subtract 3 is negative 3. 1 subtract 1 is 0. 1 minus 3 is negative 2, comma 1. So there's those 3 coordinates. And can you get the pattern? So it looks like I'm going to be going up, 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 up. And then, so there's going to be a flattened asymptote. Where is that flattened asymptote going to be? Negative 1, because remember, it would have been at 0, but we went down 1. Okay, now we're going to understand the relationship between exponential graphs and log graphs. Okay, so the base here is a 3. So I'm going to go 3 to the negative 1, 3 to the 0, 3 to the 1. Okay, so on the exponential function, so this is an exponential function right here. The coordinates are going to be negative 1, comma third, 0, comma 1, 1, comma 3. Okay, so again, when you do exponential, your coordinates are always what's the exponent, comma, what's the result at the end. So now we're going to learn how to go with that to a log. Okay, so a log is now going to take all these coordinates and switch. So this is kind of what we would call an inverse, right? The x and the y switch. Because on a log, you're going to go results, comma, exponent. Because remember when we did logs last week, we were always trying to get, well, what was the exponent? That's what we were always trying to get. Okay, so if everything is making that switch, what do you think is going to happen to my asymptote? So this said y equals 0, so now I'm going to have an x equals 0. Okay, because what's happening here? X's and y's are all switching. Okay, so let's just draw what they look like. Okay, so this is the exponent form. So base 3, it's growing, 1 comma 3, so that's what the exponent graph looks like. We've done. Okay, so let's try a log graph. So we had these 3 points. We had 1/3, comma, -1, 1, 0, and 3, 1. And then we said we had an asymptote at x equals 0. So can you determine what the shape would be? There you go. Okay, so inverses, do you remember properties of the inverse function? Switching x's and y's. You're diagonally reflecting. Do you see a diagonal reflection? Does that make sense? Do you see it? Properties. So what's the domain and range of this graph? So this domain would go forever left and forever right. And what's the range? What's the lowest? You'd be 0 height, round bracket, because you don't touch 0, up to infinity. So do you remember the properties of inverses? If x and y switch, what do domain and range do? They should switch. So does the domain equal the range of this one? Is it 0, infinity, domain? Yeah. And does the domain match this? Yes. Okay, see that switch is happening. Those are all properties of inverse function because that's what logs and exponents are to each other. Okay, so we're going to graph down here. We're going to do another log graph. So what is the base on this equation? What is the base? You have to identify the base. Okay, so the base is 5. So once I have a base, I just do the same thing. 5 to the -1, 5 to the 0, 5 to the 1. Okay, because this is a log, how do I write log points? So you have two choices, exponent result or result exponent, because it's a log. Okay, because it is a log, we are going to write it as a result, comma, then the exponent, because in a log equation, we always are like equals the exponent at the end. Okay, now transformation talk. What is this negative? What is this 2 part? What letters would you attach them to? A, B, C, or D? I would put an A there. It's in front of the function. And a C. So we're going to be going right to and negative y. Okay, so 1/5 plus 2 is 2 1/5. And then positive 1. 1 plus 2 is 3, comma, still 0. 5 plus 2 is 7, comma, negative. Okay, we're going to have an asymptote somewhere. Do you know where that asymptote is going to be? So remember where it was here? Up and down at 0. But what happened here? We moved it right to. So do you see it? Your points kind of gave you that hint, right? They started curling there. Okay, so asymptotes on that one only move if you move it right or left. The other exponent asymptotes only moved if you went up or down. Okay, one more. Okay, can't graph it. First of all, the format of it, I don't like it. What's wrong with the format? B needs to be factored out, okay? I caught half of you on the last test forgetting to factor out a B. So negative 1 is out. So this would be a x, and then this would be a minus 4. So there you have your B and your C. Okay, what is the base on this thing? 10, right. Okay, it's not there. Do you remember that one? That was the secret one. If it wasn't there, you're using a 10. So here I go. 10 to the negative 1, 10 to the 0, 10 to the 1. So this is a log. So how do I write coordinates on a log? The result, then the exponent. Okay, now I'm going to do the ABCD stuff. So it looks like we have to divide by -1 and then go right 4. And then nothing to the y's because we don't have an A or a D. How about should we make a deal here? I'll do all the y's and you guys can do all the x's. Sound like a good deal? Okay. 1/10 divided by -1 is -1/10 plus 4. So what do you get when you have 4 and you go down 1/10? 3 and 9/10. 1 divided by -1 is -1 plus 4 is 3. And then 10 divided by -1 is -10 plus 4 is -6, right? Okay, where's the asymptote? We have to shift it to the right 4. So there it is. And then it looks like I'm going to curve. Okay, and that looks appropriate because I remember what the log shape should look like and it has reflected. Okay, how about you get a piece of paper out and just... Okay, so make sure you understand the order that you're putting your coordinates in. You always start the same way, doesn't matter, you just go base to the -1, base to the 0, base to the 1, get some results, and then decide how you're going to write your coordinate. That's where you make the switch, when you write your coordinates. And then ABCD stuff after. Okay, so first things first, I should recognize that this is an exponential form. So I'm going to be doing exponent, comma, result on my coordinates. Okay, the next thing I do is identify what the base of this thing is. What is the base that you're working with? Is the 2 the base or the quarter the base? The quarter is the base because it has the exponent on it. So the quarter is the base. So I always start the same way. A quarter to the -1, quarter to the 0, quarter to the 1. Okay, so negative exponents make things flip. So 4. Anything to the 0 is 1. Anything to the 1 is itself. Okay, so my coordinates are the exponent, comma, the result. Now, what is this? This is a because it's in front, multiplier in front. So what do I have to do? I have to multiply all the y's. Okay, so you guys have a nice little graph on your paper. So draw those 3 coordinates in. It's an exponential, so it will have a horizontal asymptote. Okay, go to logs number 8. Logs number 8. Sorry, I don't know what page exactly it is. Yes, I do. Probably page 6. Okay, that matches number 8. Okay, so this is a log. So what am I going to be doing? I'm going to be writing my coordinates as the result, comma, the exponent. What is the base of this thing? Did you pick? 2. That's in the base position. So 2 to the negative 1, 2 to the 0, 2 to the 1. So I started all the same way, but now this is where I switch because my coordinates have to go backwards. Result, comma, exponent. Result, exponent. Okay, now I identify what letter, A, B, C, D stuff. A and a C. So what do I do with those? I need to go left 1 times by 3. Okay, all that's old stuff. You should be masters at the ABCD stuff. Okay, now where is my asymptote? So I moved left 1. So I'm going to have an asymptote at left 1. So I always have to approach the asymptote when I get there.